My name is Kobi Magnezi. I'm product manager for GKE Kubernetes Engine, and I'm excited to be here with Josh Hoak, a senior software engineer from my team at Google. We are here to talk with you about a non-trivial mission we have to release Kubernetes versions into a GKE fleet. And I'm going to share with you also how this process has evolved over time to meet different market needs and expectations. I do have one quick fun fact for you. Who here is local from Spain? All right. So my name has something to do with this city, Barcelona, Kobi. So in 1902, the Olympic Games took place here in Barcelona, and then Moscow, there was a cartoon mountain dog called Kobi. So for my entire high school, I was Kobi from Barcelona. And I just created this updated logo for you guys today. Alright, so what can you expect from this session today? One, we're going to speak about, give you some introduction to Google Kubernetes Engine and how we create Kubernetes clusters in the cloud and how we integrate Kubernetes into GCP. We will speak about the GKE release process and the reasons that this process has evolved over time. And we are going to share with you some exciting changes that we are going to apply to our release process. And we'll end up with talking about practices and tools that we provide you, the customers, to manage risk and control disruptions. So before we dive into the release process, I want to start with kind of a brief introduction into GKE. So how do we ship containers to the cloud? So Kubernetes is an open source system that allows us to deploy and manage containerized application. Google Kubernetes Engine is a cloud service that allows you to use the cloud infrastructure and manage Kubernetes instances. And as with any other cloud service, you can interact with your Kubernetes cluster when it's in GKE using three ways, either the API, the command line, or the UI. So we have a Cloud Console website UI that you can use to manage your cluster. It takes about 3 minutes to create a GKE cluster. When you create a GKE cluster, or Kubernetes cluster in GKE, we interact with the GCP infrastructure, with the Google Cloud Platform, to create VMs for both your master and the nodes. Once a Kubernetes cluster is created, most users will usually interact with the clusters using kubectl. Now I want us to zoom into each one of these pieces here, starting with the master. We run more than 50 different components in the master. This is just a sample of the things that we are running in the master. They include the obvious things like API server, etcd, kubelet, core DNS, ingress, and others. We also manage the software that runs in the node. So the node is where your application, or this application, is actually running. But we also manage the software that runs on the node. That includes the operating system image, the kubelet, and other add-ons that runs on the user project, namely Istio, Knative, and other components for logging and monitoring.
Right, so when I think about the challenge of releasing Kubernetes in this world of GKE, it's not just about releasing Kubernetes, it's also about releasing, as Kobi talked about, Istio and logging and monitoring and so on, right? So there's a lot of things, like the master components, right? All of these are part of the release, and then we attach a version number to that.
And so let's look at the version number itself. So the version number has, you've seen this before, it has two parts. It has what we call the vanilla Kubernetes version. That's the 1.13.5, the major minor patch. And then we have our GKE specific patch number on top of that, the GKE.10. And so all of our version numbers in GKE look like this. And that's because at the end of the day, the GKE.10 is specifying the patches that we've provided on top of it. And it's because this version number is our version number for all of our software. It's the version number for the OS image, the Kube API server, the kubelet logging, and so on. It's our kind of our bundle ID. And what makes this challenging is, well, of course, Kubernetes is releasing very, very fast. If you compare it to like Go, which releases every, say, 6 months, Kubernetes is releasing every quarter. And that's quite challenging. But when I think about the release of Kubernetes, I'm not even just thinking about the release of say, minor versions, I'm also thinking about like the milestones that we've seen, and we've seen a ton of huge milestones. So just to give you a little story, when I came to GKE, I came in 2016, and it was like 2 months later, and I was like sitting at my desk, and like someone was playing on their phone. I was like, they're playing this game. I was like, oh, that's kind of funny. And then someone down the hall was playing this game too, and then I walk outside, and some people are playing this game, and then later that evening, like everyone is playing this game, and like, what am I talking about? Like, I'm talking about Pokemon Go was launched on GKE, and I was like, whoa, what is this thing? And I was like, for me, this was incredibly impactful because I was like, oh, GKE is not just a toy thing, it's real. And then, from there, we started to launch more and more features on GKE.
So we launched regional high availability clusters. Istio was announced. We also experienced some security incidents. We launched GPU support on GKE, private clusters.
And just to pause right there, GPUs for me are like a big deal because about a year ago, the talk I gave at this conference was about MiniGo, which was we were building a AlphaGo kind of inspired Go AI, and so we built that using Kubernetes, and we couldn't have done that without having GPUs, and it was like super easy, given the fact that the GPU integration in Kubernetes is great.
And then just recently, CNCF conducted a survey that shows that 73% of the industry deploy containers. That's pretty amazing. And then recently, we announced Anthos. So the reason why we are thinking about these events, and there are other milestones, obviously, but we highlighted this specifically. And thinking about this, we grouped them into 3 themes. And those themes really impact the way we release versions into GKE. The first one is market adoption. If you think about the timeline that Josh just described, back in 2015, probably the technology, Kubernetes technology, was mainly used by very tech-savvy company, startups. But nowadays, we see the amazing adoption of Kubernetes, and we see other industries, financial services, healthcare providers, and large enterprises using Kubernetes in production. For us, it means that we need to rethink the way we release versions into GKE. We need to take into consideration internal processes for this large organization. We need to consider compliance, regulation, and other issues that may impact the cadence and the nature of the releases that we are releasing. The other thing is we're supporting variety of application. We're supporting stateful application, stateless application. And with that, we also support the growing ecosystem. So we have more add-ons, more partners that we are integrating with. And finally, we are also enabling cloud infrastructure on Kubernetes. So if you want to use GPU, TPU, or networking features, we are doing the integration between the cloud and Kubernetes. That really requires us to carefully think about our releases and balance between velocity and stability.
Great. So I'm going to give a high-level overview of the release process. Of course, the release process is very complicated. So I'm going to talk about several different ways we can think about the way that we do releases. So the first is kind of a process view. Like when I think about the release process, I kind of break it down into 5 very core steps. So one is develop. People are working on various parts of the Kubernetes and the add-ons. And then we build, which is, for me, that means we're building Docker images, and we're pushing those to, say, Docker Hub, or we're pushing those to Google Container Registry. And then there's a packaging step, and I see these as different because for me, now that there's a Docker image, now that goes in, say, some Kubernetes YAML files, and from the Kubernetes release, we'll take the Kubernetes tarballs, and we have to group those together, and then we qualify them. And the qualification is both like testing, and it's also a soak time. So we have a test environment where we qualify it for quite a long time. And at some point, could take weeks, sometimes even months, we'll decide to cut a release candidate, and then we'll roll it out to production. And all of this happens with, again, that Kubernetes version number, because really it's our ID that says all of the things that we're bundling together. And then just to go back to rollout, our rollout happens over 4 days so that, if something breaks, and hopefully it doesn't, but that we'll catch it on, say, day 1 or at worst day 2, and that day 3 and day 4 are hopefully not affected by the rollout. So what are we rolling out? If you look at our release notes, we talk about 2 different sets of versions. And we talk about 2 different actions that we're taking. So the 2 different versions are the master version and the node version. Now, the master version is the version for all the software that we're releasing on the master, but also, as Kobi mentioned, the add-ons, right? Because those are managed by us. And the node version, it turns out not to be very much stuff, but it is important, and that is the OS image version and the kubelet version. And then going back to the actions we can take are either, here are these available versions for you, or here are some upgrades. So for upgrading the master, here's kind of what I just described in picture form. A master upgrade will upgrade everything on the master, OS image, all those components, and it's also going to upgrade those add-ons. And a node upgrade is going to upgrade just the OS image and the kubelet. But this is important because we have to ensure that the kubelet stays within some range of the masters. Now, the management of the Kubernetes nodes is kind of a shared responsibility. If you opt into node auto upgrades, we'll do it, and if not, then it's kind of your responsibility. But it's important that these things kind of stay closer together. So over time, we've tried to encourage more and more people to go with node auto upgrades because the skew can really be a problem as Kubernetes is a fast-moving product. Okay, so here's another lens that I like to think about when I think about the life cycle of releases. And that's the version life cycle itself. If you look at GKE and you look at our release notes, we have 3 different minor versions at any given point that we offer. There's an N, N+1, N+2, and that's because of the life cycle of their versions. When we release a new version on GKE, it's what we call like a new version, and that means you can create clusters at it, but we think it's GA, but there might be bugs, right? But again, these are the new features that you can use are in this new version. After about a quarter, we're going to move over to making that the default. We think that there's had enough soak time to be the default version, and that's where we recommend most customers be, is on the default version. And then after that, we're in the phase-out period. And it's in the phase-out period is where we do our master upgrades. First, we do the master upgrades, and if you've opted into node auto upgrades, we upgrade the nodes. And it's important to do it this way because if the nodes are ahead of the master, things get pretty funky. So you have to ensure that you do the master upgrades first, and then you do the node upgrades. Patches in GKE, and these could be either Kubernetes patches or the GKE specific patches, have a very short life cycle, but they are very similar to the minor versions. Again, just shorter. So this is on the order of weeks rather than months or quarters. So a new patch will come out. We'll see how it's doing, and then after about a period of a couple weeks, we'll upgrade people within that minor version to the new patch. So just to pause here. This is kind of a summary of where we are with the GKE release. And we've talked a little about kind of like upgrades. We've talked about kind of like process at a high level. And we've talked about this version lifecycle. But everything is tied right now to this kind of version identifier. And as Kobi mentioned, we're moving towards a world where more add-ons are moving onto GKE, more partners are using GKE. And so GKE is becoming this platform for applications. Not just sort of for customers, but for us. And so what are we doing about it? And so one of the things that I've been working on is component-based releases. And so component-based releases is the idea that instead of having a whole life cycle around, say, for the version number, let's have a life cycle around components. And so one of the things that I've been working on over the past 6 months is this project called the Cluster Bundle, which is a project that aims to sort of open source the tooling and infrastructure for building and managing components. And it's something that we're using both on GKE and on GKE on GCP and on Anthos. And you can check it out here. So what is the Cluster Bundle? I'll just give a very brief overview of what it is and why we use it. So what it is really just a very, very lightweight packaging solution. So we stick a name and a version onto some Kubernetes objects. And when you look at the YAML file, this is kind of all it is. And you might be thinking, like, why is this interesting? And I think it comes down to the philosophy of what this means. Really, everything in this world is a Kubernetes resource. And so this is kind of a powerful way to think. So yes, we're going to have, say, our etcd, we're going to have our controller manager, whatever, our Istios as the deployments, RBAC rules, and so on. But we can also have CRDs that represent application metadata, CRDs that represent runtime patches, CRDs that represent dependency requirements. And then everything is bundled and versioned into this component. So if we take a look at that lifecycle diagram before, now it's much simpler. It's the same, but instead of qualifying that big version thing, now we're qualifying components. So we're taking that, we're packaging it into components, and then we qualify, and then we roll out components. So what does this mean? For the end user, you might not see very much, except for us it means granular qualification. It means improved release velocity for components. And also something I'm very passionate about is it means common infrastructure for releasing components. So I've been working on this for GKE on GCP and Anthos. I've also been talking with people in SIG cluster lifecycle. I know that Justin Santa Barbara has been working on add-ons, and so he's been using this for add-ons. And we've been talking with the COPS folks as well. So super exciting. But this, for us, this is only part of the story. And I want to turn it over to Kobi to complete the story about how we're trying to solve releases.
Cool, thank you. So I'm not sure how many of you are up to date with Game of Thrones, but this is not a spoiler. But in one of the recent episodes, many people noticed a completely misplaced Starbucks cup in one of the scenes. Evidently, a mechanism for managing risks and controlling disruption is important. So far we spoke about velocity, but we also want to make sure that with the growing market adoption that I mentioned before, we cater to different customers. And we spoke with many customers, and we realized that one size doesn't necessarily fit all. We have different customers, different market segments, and different needs. So just to give you some example, customer A may have a multi-week certification cycles for every release. They're looking to align it with their internal processes. Customer B doesn't use really auto-upgrade, but they upgrade manually to get better control. They're very excited about the ability to test early version of Kubernetes, where customer C, they are very self-sufficient, they know how to use Kubernetes, and they want to adopt feature quickly or quicker and roll them out to multiple clusters. And they want to also maybe validate the features and the releases on staging environment before they roll them out into the production. So with that customer perspective in mind, we realized that we need to provide a more simple and streamlined process for customer to choose their version. So as we explained before, right now you can choose the specific version. We are actually moving away from that structure to a concept called release channels. So we are going to offer 3 release channels. Actually, just 2 weeks ago, we launched alpha of release channels. With release channels, you can subscribe your cluster to one of these release channels. So let's say you are keen to try out the new features or the new releases from Kubernetes, you can use the Rapid channel to get the most up-to-date and fresh releases coming from the open source community. If you want to run your production workload, you can choose either the regular or the stable. The main difference is really about the soak time that Josh mentioned before. So it's the stability and freshness of this version. We also think about the way we mature the version. So the more soak time, the more time it accumulates, we will promote a feature from the Rapid all the way to stable. Another way to manage risk is transparency, and transparency is key for us. We provide visibility into our release scope on the GKE side. And you can see more than just a changelog on our release notes. You can actually see the 4 days rollout that Josh mentioned before. So for every version that we are making available, you'll see in each geographical location it's going to be available. You also can see when we are going to deprecate a version and what feature are included in each version. With the introduction of release channels, we changed the structure of the release nodes. So as you can see here in the screenshots, we have this tab structure, and you can choose which channel you want to see the release nodes for. As we explained before, you have the option to choose whether or not to auto-upgrade your nodes. If you opt into auto-upgrade, you can do it through the UI, you can see it on the right side, or through the command line. We highly recommend you to turn on auto-upgrade. The Kubernetes open source policy required the master to be within 2 minor versions from the nodes. So that's really important. But then again, we spoke about the balance, right? Velocity, disruption. We want to make sure that as we encourage you to keep your cluster up to date, we also provide you with ways to reduce disruption. We just recently launched as alpha node surge upgrade. That means that we changed the way we sequence the node upgrade workflow from delete then create to create then delete. What I mean by that is at the time of new version availability, we will create a new node in your cluster with the new version. Then we'll gracefully drain the old node and just remove it. And that ensures, one, successful completion of the upgrade. It also secures the resources before we even start an upgrade, and it reduces the disruption and the downtime for your specific cluster. We ran some tests, and it's pretty amazing to see the differences between the disruption period in the current sequence and the disruption period with surge node upgrade. We also recognize that there are different businesses and different type of business needs, and different customers may have different peak seasons. So if you are a retailer, for example, you might want to avoid upgrade during Black Friday, Cyber Monday, or if you are a gaming company, maybe you want to avoid maintenance events during weekends because you get most of the traffic during weekends. With maintenance window, today, you can specify 4 hours maintenance windows, which we'll respect, and we will make sure that we initiate maintenance events such as upgrade only in these 4 hours window. And then in addition, we are expanding the capability of maintenance windows to cover other use cases. For example, if you're trying to avoid upgrades in specific days, or if you're trying to block out specific range of dates, let's say the holiday season or Black Friday, Cyber Monday. And the last thing is you can also snooze an upgrade. Let's say you know about an upcoming upgrade, but you need some time to get prepared for that upgrade. You will be able to snooze an upgrade for a short period of time. And then the last feature that we are introducing for managing disruption and reducing risk is Canary Clusters. So I mentioned before release channels. That's great, but we also recognize that you have risk mitigation plan, and we want to help you with those plans. With Canary Cluster, you can create a cluster designated for Canary usage or staging, and then link it with one or more of your production cluster. What it means for us is we will instruct the release server to roll out new versions to your Canary cluster first. We'll give you the opportunity to test out new version, either through running your automate test, or we can trigger your automate test for you. And then once you green light the upgrade, you make sure that nothing breaks, the release server will roll out the upgrade to your production cluster as well. So with these changes that we just described, we spoke about growing market adoption, growing ecosystem, evolving cloud infrastructure. We want to make sure that we keep this balance between velocity and low disruption. We will still have to face with the quarterly releases of Kubernetes, but we also want to make sure that we meet customer needs. We are evolving basically from a cluster creation cloud service to a platform that supports both the extension of the platform through add-ons and partners, and also support different types of customers and users. Thank you.